To factor, that means it's a trinomial. First and last term are perfect squares. Perfect exact same number. 16 is 4 times 4. So 16 is a perfect square. If you took the number 8, 8 does not break into two of the same number, whole numbers. So 8 would not be a perfect square. So examples of perfect squares are 1, 4, 9, 16, 25, 36, 49, and then they go on forever. Okay? Yep. Now when you're talking about variables, x squared, x to the 4th, x to the 6th, x to the 8th, x to the 10, notice that all of those are even powers. Okay? Like if I had x to the 20th, I could break that into x to the 10, x to the 10. Had it been x to the 11th power, then one would be a 5, one would be a 6. That would not be a perfect square. And so if you have a problem like this, x squared plus 2x, or x squared plus 10x plus 25, that is a trinomial. A is 1. So if you wanted to, you can make that little x, where you try to find two numbers that multiply to 25 and add to 10. What are those numbers? What multiplies to 25 and adds to 10? 5 and 5. So your answer would be x plus 5, x plus 5. Or you could also recognize that x squared breaks into x and x, 25 breaks into 5 and 5. That means they're both perfect. And so you'd get x plus 5, x plus 5. Okay, you copy that sign over twice. Okay. Second? Yes?
If it's x plus 5, can we write like x plus 5 squared?
Oh, yeah. So he's saying, can I just save space and write it as like this? Yes, you can. Yeah, that means x plus 5. X plus 5. Yep. Okay. Those mean the same thing. Good question. So x squared minus 10x plus 25, we still have a perfect square, x and x. We still have a perfect square, 5 and 5, but now you're going to copy down a minus on both. 4 x minus 5 squared. And if you wanted to, a is 1, multiply the 25 and add the negative 10. So why would you memorize a special formula? Well, 1. Like 9x plus 24x plus. So when I take 9 times 16, whatever that is, and find two numbers that multiply to 9 and 16, but add to 24, and then once I find those two numbers, I break 24x into those two, factor the left, factor the right, a lot more work. But if you recognize it's a special case, and you go to what? X squared. 3x, right? And 16 breaks into 4 and 4. So that means the first and last terms are perfect squares. And so I would get 3x, 4, 3x, 4, copy down the plus sign twice. That was a lot faster. Now I would encourage you, because this middle term, you still need to kind of distribute and make sure whenever you use a shortcut that you get that middle term. So 3x times 3x is 9x squared. 3x times 4 is 12x. 4 times 3x is 12x, making 24x. 4 times 4 is 16. Sometimes they try to catch you off guard, and they'll change that to 25x, and you'll do the special formula, and then it'll actually be the answer. It can't be factored in that case. Okay. So any questions on how to factor a perfect square trinomial? Yes? 3? Right here? Because 9x squared breaks into 3x and 3x. Right? Like had that been 16x squared, it'd be 4x and 4x. Right? Does that make sense? Now, there's also a special thing you could do when you have squares, and you use this when there are two terms. So it's a and there's okay, and x squared minus 9. So if there's two terms with a minus and two terms, is 4 a perfect square?
Yes.
It is 2x and 2x. It's 3 and 3. Now there's no middle term here. And the reason why there's no middle term is because you're going to put a plus minus. Okay? Because these are exactly the same with a plus minus, that's how you get rid of the middle term. Okay? 2x times 2x is 4x squared, negative 6x. 3 2x plus 6x. That's why the negative 3, negative 9. Okay? 5.
5x plus and minus 49 is 7.
Mm-hmm.
And 5x minus 7 and 5x minus plus.
Right, so as long as one's plus, one's minus, you could do minus then plus or plus and minus, same thing. So as long as you have one plus, one minus, you're good, okay? And then finally, 16x squared is a perfect square, so is 81. So that would make 4x 9, 4x 9, 1 plus, 1 minus. Now, in your homework, it'll be like 16x squared plus 81. For now, you could put, when it's a plus sign in two terms, you could put not factorable, okay? It actually does factor into imaginary. So if this is a plus 81, when I see you on Thursday, the only thing that's going to be different is that this will be 4x plus 9i, 4x minus 9i. So when that's a plus sign, it ends up being an imaginary factor. Huh? So you could go ahead and do that, or you could put not factorable, yes.
So imaginary factor is I.
Yeah, so had that been a plus, that'd be plus 9i minus 9i. And I'm going to show you more of that on Thursday. Another thing they like to do to confuse you is like if they said the factor 8x squared minus 18. So how would you factor that? How does 8x squared, is that a perfect square? It's not. So you can't use any of this stuff unless it's a perfect square. But when you factor, you should always look for GCF. And is there one?
Yes.
Yeah, it is. 8 doesn't go in 18.
2 and
2 is a factor, but there's a bigger one, a greater one.
bigger one.
Or there is not, right? I was wrong. It's actually 2, right?
There is not.
4x squared minus I. And then, usually when you factor out, oh, there's the perfect square, 2x, 1 plus, 1 minus. Okay, so you should always look for GCF.